Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So we are going to proceed with 2.2 atmospheric pressure. So in the previous subtopic, you have learned about liquid pressure. So liquid pressure is the pressure due to the weight of the liquid acting on the object. Okay, so now atmospheric pressure is actually the pressure due to the weight of the layer of air acting on the surface of the earth. Okay, so we know that the earth, okay, is surrounded by a thick layer of air which is trapped under the atmosphere. So these layers of air consisting various types of gases such as oxygen, nitrogen, carbon dioxide and so on. So the air will exert it has weight and it exerts pressure on the surface of the earth. So that pressure is called atmospheric pressure. Okay, so how do we determine the value of atmospheric pressure? Okay, this is one simple method which is using mercury barometer. A simple mercury barometer consists of only mercury, glass tube and also bowl. So that's all what it takes to make a mercury barometer. So first we fill the bowl, okay, fill a bowl with mercury, full of mercury. Next, we fill a glass tube, also full of mercury, and we cover it with lead. So, and then we place the mercury inside the glass tube, inside the bowl, and remove the lid. So what happened is, okay, so this is the the diagram of how it will look like. And then what happened is, the level of mercury in the glass tube will drop. Okay, it will drop to a certain height. Okay, so this is the final diagram. So this is how it looks like when the level of mercury drop, and when we measure the level of mercury in the glass tube, it is a constant number which is 760 mm or 76 centimeter, and above it, okay, is vacuum. Okay, it is vacuum. It is not air, it is vacuum, because in the first diagram we fill it with mercury full to the lid. Okay, so when the level of mercury drop, what happens is the air inside it is actually vacuum. It has no particle also or anything else. Okay, so here what happened here is atmospheric pressure acting on the mercury here. Okay, and when we measure the level of mercury, it turns out to be 76 centimeter. So we can say that atmospheric pressure is equals to 760 mmHg. Okay, so what is Hg? Hg is mercury. Okay, so this is the standard unit for mercury. Okay, number one, let me flip pen. 760 mm mercury, or sometimes you will see 76 centimeter mercury. Okay, so now what happens if you want to use Pascal? Okay, so you know that Pascal is also another unit of pressure. How do we convert 76 centimeter Hg to Pascal? Okay, so next, so here is the conversion. So in the previous subtopic, you have learned that liquid pressure is equals to H rho G, where H is the height of the liquid, rho is the density of liquid, and G is gravitational acceleration. So you can use this formula to calculate, okay, or to convert the pressure. Okay, so here, if you want to find the value in Pascal, so okay, this one, so atmospheric pressure is H, height is 0.76. Okay, so just now when you measure, you obtain that the height is 760 mm. You have to convert in meter. You will get 0.76 meter times rho is the density of mercury, which is 1.36, and G, 1.36 times 10 to the power of 4, and the gravitational acceleration 9.81. So multiply everything, you will get 101396 Pascal. Or if you convert it to standard unit, you will get 1.01 times 10 to the power of 5 Pascal. Okay, 1.01 times 10 to the power of 5 Pascal is actually equivalent to 1 atm, 1 atmospheric pressure. Okay, so another instruments that we can use to measure pressure, atmospheric pressure, is 14 barometer and aneroid barometer. I'm leaving that for you to present. Okay, so here, solving problems in daily life involving various units of pressure. So just now you have learned about unit of pressure in mmHg. You also have learned unit of pressure in Pascal. Okay, there is another two unit for pressure, which is mH2O, meter water, and also millibar. Okay, so let's do some example. Okay, so this example number 1, blood pressure of a patient is 160 per 100. So I think you are familiar with this reading. In lower form, you have learned about systolic and diastolic. Okay, so the question is, what is the pressure in 160 mm Hg in Pascal? Okay, so same like what I did previously. You can use P equals to H, height of the liquid here, which is 160, and then rho, density of the blood, and density of the mercury, and G, gravitational acceleration. Okay, so here, height of the liquid column is 160. Okay, 160 is 0.16 m, gravitational acceleration, constant value, and density of mercury 1.36. So just substitute everything in the formula and you will get your answer in Pascal. Okay, next. Example number 2. The maximum pressure that a wall at the seaside can withstand is 3.6 times 10 to the power of 5 Pascal. What is the maximum pressure in meter H2O? Meter water, H2O is water. Okay, so similarly, you can use the formula P equals to rho GH, but this time we are going to use water. So we will use density of water. Okay, so the maximum pressure is 3.6. Density of water is 1 times 10 to the power of 3, and gravitational acceleration 9.81. So similarly, this is also a very simple example. Just substitute everything in the formula and you will get H. Okay, because the question wants H. First we find H first, 36.7 mm. So 36.7 m is actually the height. Okay, height of water. So since you want pressure, okay, so here in the previous page, unit pressure, meter water. Okay, meter water. So you can just simply use 36.7 meter water. Okay, so that is the maximum pressure. Okay, so this is just the conversion of from Pascal to meter water. So once you obtain the height, that is actually your maximum pressure as well. Okay, so next is the effects of ATM pressure at high altitude and effects of pressure at extreme depth under the surface of the sea. So also I'm going to leave that to you to present. Okay, so now let's go to some real example questions. Okay, so this is trial SBP 2014 question. So you are given a diagram on how to measure atmospheric pressure. So name the instrument in diagram 3. This is actually Mercury barometer. Okay, what is the value of H in centimeter Hg? Okay, so you know that H is 76 centimeter Hg. So the height is simply 76 centimeter. Okay, next. Based on the answer in 3B1, determine the value of H in unit Pascal. Okay, so we have the formula rho times G times H. So rho is the density of mercury. Density is given 1.36 times 10 to the power of 4 kilogram per meter cube. G is gravitational acceleration. We use 9.81 and height is 76. So just substitute everything. 1.36 times 10 to the power of 4 times 9.81 times height 0.76. Don't forget to convert to meter and you will get 1.01 101,396 Pascal. Okay, or you convert to the standard form 1.01 times 10 to the power of 4 Pascal. Next, what happens to the length of H when the instrument is brought on a high mountain? Okay, so at high mountain, you know that the atmospheric pressure at high mountain is low. Okay, so based on the formula, P equals to rho GH. So if the atmospheric pressure is low, then the height will also decrease. Okay, because H is directly proportional to pressure according to the formula. So when pressure decrease, height will also decrease. Okay, so that's all for this subtopic. So I'm going to leave you with an assignment. Thank you.